Good morning, everybody. My name is Jamie Hughes, and here with me today are Aaron Kilpack, Matt Matucci, and Jamie Law. Today, we will give a brief explanation of our senior design project, followed by a demonstration of our product carried out by Adam Irvin, Brock McCloy, and Zach Roberts. If you read the background portion, you'll see that there are quite a lot of people afflicted by eye-related conditions. Dr. Crandall and his team at Moran have increased the availability and accessibility of difficult to obtain eye care through their local and international outreach program by training and performing surgeries in underdeveloped areas around the world. So what does this have to do with us? Well, through observation of their processes and interviews with a few of their team members, we discovered three major areas that limit the efficiency of their operation. One, no way of isolating a patient's head from moving during eye exams. Two, battery-powered devices that they use drain quickly with no way of recharging them on site. And three, limited access to flat tables or workspaces. In an attempt to prioritize these difficulties and figure out which one we wanted to solve, ultimately we decided to tackle all three. We created a multifunctional, robust solution in the form of a modified storage case. We started with an empty Pelican Air 1615 case and added a battery bank capable of providing power on demand, legs and extendable slides so the lid could be removed and function as a table, and a collapsible head support that attaches to the table to help isolate a patient's head movements during examinations. So let's hear a little bit about the key features of our design.
So some of the key features for the head support is that it's quick and easy to assemble. It's compact and easily stored inside our Pelican, and it can easily attach to any flat surface, and it is more than capable of holding 10 pounds.
The deployable table functions appropriately, holding 50 pounds, but what does this table include? Aluminum adjustable hiking/trekking poles for the legs provide 1.5 to 4.5 feet of table height. The lid itself does not provide much table space, so 2 tabletop slide outs add table space for this. These also provide a great place to clamp the head support for portable slit lamp examinations. The legs and slides are mounted to a 3D printed frame on the bottom side of the lid for easy setup of the table, as will be demonstrated in a few minutes.
The power bank contains 3 lithium polymer batteries that provide enough charging capacity to charge all of Moran's commonly used equipment at least once during a workday. It also includes an exterior AC power outlet to provide power to any miscellaneous components that Moran might use. It contains 2 exterior USB outlets that provide the ability to charge 4 devices simultaneously. And finally, it contains a cooling system that keeps the electronics operating at optimal temperatures.
So here is just some of the testing that went into our project. For the head support, we chose to 3D print the pieces that hold your forehead and your chin in place. It's just a cheap and easily manufactured alternative to what you would normally see in an optometrist's office. For obvious reasons, we had to test it out to make sure that it could support the weight of the human head. We essentially had weights ranging from about 0.5 pound to 25 pounds suspended from the center of the part, and we wanted to see how these parts would react to all the weight, whether they would start bending or cracking. At the end, these parts were able to support up to 25 pounds, and under the assumption that the human head weighs about 11 pounds, these parts were more than enough to hold a head. And you also have to take into account that while your head is in the support, your body is still supporting your head. So honestly, it doesn't even need to support the full 11 pounds.
On the electrical side of things, it was important for us to provide supplemental power to the outreach team in a variety of environments. Earlier calculations predicted that we would be able to provide Moran with roughly 3 hours of extra power. And to confirm that these calculations reflect reality, we conducted discharge tests on our battery bank by drawing 1 amp and measuring the voltage every hour, which produced the discharge curve shown. This data was able to be extrapolated to other loading scenarios and validated that our battery bank can provide the Moran outreach team with at least 3 hours of extra electricity, as we claim. Additionally, we wanted to confirm that the battery bank would reliably function in even the hottest expected environments. In some of the areas that the outreach team visits, the ambient temperature can reach well above 100 degrees Fahrenheit. And with the maximum operating temperature of the batteries being 140 degrees, we felt it necessary to implement a cooling system that would reliably keep the internal temperature of the electronics housing below this max temperature. To inform our decision-making, we produced a variety of computational fluid dynamic models for each iteration of the cooling system, and the final CFD model is shown here, and it verifies that the electronics will be kept below the maximum operating temperature.
Testing the work table consisted of verifying that our chosen design would hold up under the demands that we expected it to face. We set an initial goal of supporting between 40 and 50 pounds and conducted a finite element analysis on the design to verify that we could achieve this. Once it was assembled, we loaded the table up to about 45 pounds and feel confident in saying that it will support up to 50 pounds. As a buffer though, we recommend not exceeding 40 pounds, which is still more than double the amount of weight we expect Moran to place on the table. We also set a working height requirement between 36 and 40 inches, which is easily accomplished with the adjustable table legs.
To wrap things up on the design phase of our project, we went to Moran Eye Center to resolve problem areas in their outreach program. Very unfortunately, a few weeks into the 2020 fall semester, the main surgeon for the outreach program and an amazing person, Dr. Alan Crandall, passed away. Despite the tragedy of his passing and losing contact with Moran Eye Center, we met our overall multifunctional design metrics. We hope that this can help more people that experience eye problems around the world. Here is a demonstration of our functioning product.
We chose the Pelican Air 1615 because it's lightweight, it's rugged, it has wheels, and it has an extendable handle. Let's take a look at some of the outside features.
So on the front, you can see our two USB ports for charging devices. They have voltage readouts that measure the battery capacity of our battery bank for convenience. On this side, we have our AC outlet as well as the exit to the fan of our cooling system when that's running. Let's take a look at the inside. On the inside here, we can see our electronics housing, and inside the housing, there's a couple things like the inverter, fan, USB ports. One of the main design requirements of our case was that the batteries are removable, so they easily slide in and out, and we can see you can easily slide it in and connect it, and that's that. Let's take a look at our lid.
We've modified the hinges so that the lid can easily be removed. We've also added a frame to the inside of the lid to house our table slides as well as our fold-out legs. We'll look at those now. Now that our table lid is assembled into a table, we come into our case and you pull out our headrest. It's designed to hold your head in place while Moran Eye Center looks at your eyes. And then you tighten it. This headrest can go on either side. And then once you get it on there nice and tight, depending on how big or small your head is, you can adjust. I'm gonna give my chair. Come down, put your chin there, and then lower it as such. This concludes our Moran project for the year. Any questions, concerns, or comments?